Hello, Shahad Ahmed here. So now we are at the last part, the third part of our organic nomenclature. In the first part, we learned the word root, like what is meth for, is for, and then we went on toward the primary suffix that in alkanes. In the first part, we discussed that for alkane we use a and e. Then we went on and discussed the secondary prefix, like all the substituent attached to our compound. So we discussed the rule for that, which substituent gets priority or which one, the alphabetical order, and then also we discussed the name, the rules for the name, like how laterally to write the name, like the rule for a hyphen. It was used to distinguish, to give gap between a number and a word, and also discussed rules for comma. And then in the second part we discussed alkenes and cycloalkenes, okay, and also discuss some other substitution to the secondary prefixes. But here in this part, this is specially designed this way. During this video, we will discuss all the necessary functional groups. So from this name, you would have infer that here one of our functional groups. This did not appear in our previous videos. So now we have got a functional group. Where does the name of the functional group appear in our skeleton? So the skeleton has already been fixed, the word root in the middle, and from its one side we have prefixes, and from the word other side of the word root we have suffixes. So the secondary suffix will show our functional group. The secondary suffix is the real signature of the molecule. So here in this case too, this compound's functional group is appeared in the secondary suffix. So I'm not gonna go to the detail of this one because we will discuss them, the alcoholic functional group, later in detail. So one by one, now I'm gonna discuss all the functional groups one by one, by their priority. Okay, then we will also discuss what happens if the combination of functional groups comes in a compound, which one gets priority or which one, and how to name in the our compound in this case too. So now I will start with our functional group. The first one is carboxylic acid. I'll start with that one. Now we are in position to discuss carboxylic acid. The one thing in addition to what we have learned already is that secondary suffix used for carboxylic acid is oic acid. So now you must be able to name this compound. So the basic operation remains the same. What is addition to that is the secondary suffix. Other than that, all the rules remain the same. Okay, so we must name now here. We must number the longest carbon chain as in the previous cases we did. But here we will start the numbering from the carbon that is the closest to our functional group. So the functional group carbon here, this carbon is number one. This becomes two and this becomes three. So we have discussed the word root for three carbon atom is prop. So as there here we see no unsaturation. So N, and the suffix for this, the signature for this molecule is oic acid. So oic. So this becomes propanoic acid. Okay. Now we'll take another example. You must answer this question. Okay, what would be, okay, what would be the name for this compound? Now here we have the option to start to give priority to the double carbon, to the double bonded carbon, or to give priority to our functional group. So here you must remember this functional group is prior than double triple bond. So functional group gets priority. We'll start numbering from this end, from the functional group end. So this becomes 1, 2, 3, and 4. Okay, so what will be the name of this compound? For 4 carbon atoms, we know that the word root is but, and as here we see some unsaturation. So at carbon number 3, we see in. Okay, we see a double bond. So for a double bond, we use in. Okay, so but 3 in and oic acid is mentioned. Okay, now here with another example, I want to clarify one of your other concepts, and I will now draw bond line notation for convenience. Okay, so now here, now you must name this compound. Here we have two options. One is to go this way for the longest carbon chain, 1, 2, 3, 4, and 5 carbons atom. Okay, and the other option is 1, 2, 3, and 4 carbon atom. So which chain gets priority over which one? Here we will take the chain, the longest chain that contains double bonds, because as discussed earlier, the double bonds gets priority over the longest chain. So in the previous video, in the second video, we have already discussed that. Okay, so now this will become our main chain. This becomes carbon 1, 2, 3, and 4. Okay, so now we have a complex substituent attached at carbon number 2, and we have already learned the rule how to name our complex substituent. That is to mention its carbon number first, then close the name in parentheses. Okay, then name the branch of our main branch. Okay, count the number of carbon atoms in the main branch, and that is to start to give carbon number 1, to give number first number to the carbon that is directly attached to our main chain. So this becomes carbon 1. Then we have to go on, carry on for the longest carbon chain, and this becomes like our longest chain. There is no other alternative. So we have got the branch, a substituent. So we must name the substituent of the substituent first. So this becomes 2-chloro, and this is now a branch of 3 carbon atoms. So for 3 carbon atoms, we have the word root prop, as this is a branch. So we have already learned that for alkyl substituent, we use YL. So this becomes profile. Okay, so this ends the name of our substituent, of our complex substituent. So we must end it with the closure of our bracket. Okay, now we must name our parent chain, that is 4 carbon atoms. So the word root becomes but. Okay, and as here is unsaturation at carbon number 3, so for carbon 3 we have a double bond, so in, and the parent, the secondary suffix for this is oic acid, so it remains oic and acid. Okay, so in these names you are seeing the gap between the acid and the other name. Okay, so this must remain the same as it is. There should be a gap between the acid and the parent chain name. Now it's our the ester comes second in the priority list of our functional groups. So what is the secondary suffix used for our ester? So it is alkyl alkanoate, okay, O8 and alkyl. So this alkyl groups should be named first, okay, and then the other alkyl group, it is written as alkano OATE, ends with alkane part of this. So we will clarify this with the help of an example. Suppose we have this compound. So we must name our alkyl part first. That becomes methyl. And free carbon atoms in our main chain. So the word root for it is prop. And A and E for as there is no unsaturation. So A and E, the primary suffix becomes A and E, and E will be dropped because of vowels coming one after another. So the secondary, this is the primary suffix. The secondary suffix become OATE. So the name for this compound becomes methyl propanoate. Okay, now we must be able to name this compound. That is CH3, CH. So now what is attached at the alkyl part? At the alkyl part we have a benzene ring attached. So the name for the benzene ring becomes phenyl. Okay, now the main chain becomes how many carbon atoms are here? 1, 2, 3, and 4. And we have got a substituent attached at carbon number 3. So 3 methyl. And the word root for 4 carbon is but. And N for what? For saturation. And OATE is a secondary suffix. So this becomes the name of this compound. On the third number, we get carbonyl chloride, the functional group like that. And the suffix, the secondary suffix used for it is oil chloride. So you must be able to name this compound now. So 1, 2, 3. For 3 carbon atoms, we have prop. And there is no unsaturation, so N. And the secondary suffix, so this was the primary suffix, the secondary suffix is oil chloride. Here I will discuss just one more rule, and then we will go on with the speed with other functional groups. So you must be able to name this compound. What will be the name of this compound? Which one becomes our parent chain? So between the straight chain and the cyclic group, we said that the one containing greater number of carbon atoms become our parent chain, as in the second video we discussed that. In the first video we discussed that. In the second video we said that the one containing the double or triple bond becomes our parent chain. But what about over here? Over here, the one containing the functional group becomes our parent chain. So here, which chain has our functional group? The cyclic one or the straight chain? So the straight chain contains our functional group. So this becomes our parent chain. So we must start numbering this one for our parent chain. This becomes 1, 2, 3, and 4. So on carbon number 3, we have got 1, 2, 3. Carbon number 3, we have got 3 cycloalkenes. prop, and there is unsaturation in our substituent. So at carbon number 2 we have a double bond, so in, and YL is used for the alkyl group used being attached as a substituent. So this becomes 3-cycloprop 2 enyl. Okay, and now our parent chain contains 4 carbon atoms, so this becomes but, and N for the saturation, and oil chloride is our secondary suffix. So the final name for these compounds become 3-cycloprop 2-enyl butane noyl chloride. So we have got our fourth functional group that are amides. So amides are named amide. Okay, so we will get a secondary suffix for amide as amide, as we will see now. Suppose we have a compound like this. What will be the name of this compound? This will be 1, 2, and 3. So for 3 carbon atoms, we say it is prop, and A in for what? For saturation, and amide is our secondary suffix. So the name for this compound becomes propanamide. What will be the name of this compound? Let's see. So now we have got a substitution at N. So at nitrogen, we have got substitution. So the name for this becomes really easy. It is N-methyl. And 3 carbon atoms is, in the previous case, propanamide. So I wanted to clarify this. If a substituent was attached to nitrogen, so we'll call it N-methyl, okay, or alkyl, anything if it was attached over there. If there were 2 substituents attached, like 2 methyl groups attached over here, what would we call it? We would call it NN dimethyl, okay? Then the name would have been NN dimethyl. NN dimethyl propanamide. So this is the name of this. Our fifth substituent is cyanides. So the word, the secondary suffix used for it is nitrile. So we must be able to name this compound because we have learned all the rules. So we must count the carbon atoms from our functional group 1, 2, 3, and 4. So for 4 we have got the word root as but, and for all being what saturated, and nitrile. So butane nitrile is the name of this compound. Okay, on number 6 we have got aldehydes, and on number 7 we have got ketones. So for aldehyde we have the secondary suffix as we use as al. So what will be the name of this compound? Says free. So the word root for 3 carbon atoms, it becomes prop. Now you have learned that by heart. And An for saturation, and Al for what? For our secondary suffix as it is aldehyde. So what will be the name of this compound? It is called benzaldehyde. Benzyl. Okay, so now we learned that for a normal aldehydes we used at the end of the name is al. So if it was attached to benzene ring, this becomes a parent. This becomes our primary functional group. It is called a benzaldehyde. If here was a methyl group attached, we would call it 2-methyl benzaldehyde. So it is now, I think you have learned the pattern of naming an organic compound with the with IUPAC nomenclature. Okay, now for ketones, we use O and one for as a secondary suffix. So you must be, you know, which side from which side you should start numbering your main chain. The main chain must contain our functional group, you know that. So this becomes our main chain. There is no other chain. So from which side we should start numbering. From this side, the double bond gets carbon 1, but our functional groups gets fourth number. Okay, but from this side, our functional groups comes at carbon number 3. From this side, it comes at carbon number 4. From their side, it comes at carbon number 3. So we must number it from the side that gives it a lowest locant. So 1, 2, 3, 4, 5, and 6. So what we have got is 6 carbon atoms, so the word would become Higgs, and unsaturation at carbon number 5, so double bond at carbon number 5, so Higgs 5 in, and the secondary suffix for our ketone is ONE, and it is present at carbon number 3, so the name for this compound becomes 5 Higgs 5 in 3 O. Now we have reached our 8th and 9th functional group. If there was OH group attached to our main chain, what becomes the name of it? Now, the secondary suffix used for alcohol, if OH was attached to our main chain, at the secondary suffix we used OL. So we must be able to name this compound now. 1, 2, 3, 4, 5. So at carbon number 2, we have got unsaturation. So the name for this compound is, this is cyclic, so this become cyclo, and there are 5 carbon atoms in it, so this becomes pent. And here we have unsaturation at carbon number 2, so a double bond at carbon number 2 becomes 2 in, and the secondary suffix used for alcohols is OL, so this becomes cyclopent 2 in 1 O or O. Okay, what will be the name of this compound? So IUPAC considers the name of this compound as phenol. Okay, if there was some substituent attached at it, we can name it like if here a methyl group was attached, we would call it 2-methylphenol. If here a methyl group, we could call it 4-methylphenol. So now you know the pattern. Okay, now you must be able to also name a compound where here it is methanamines. It is called methanamine. So two vowels coming one after another, IUPAC tells you to drop one of the vowels. So this becomes methane in amine. We have to drop the E of A and E. Okay, so this becomes methanamine. What if there was a substituent attached at another, like if it was a secondary uh, amine? Okay, let me make one. Okay, if it was a secondary amine, what would be the name of this one? So one becomes a substituent attached at nitrogen. So this becomes N-methyl. Why I took this one as substituent? Because this contains least number of carbon atoms, and this becomes our main chain 1, 2. So 2 carbon atoms means ethyl. So ethane. So this becomes ethane, and as it is an amine functional group, so this becomes amine. So the name for this compound becomes N-methyl, as we have a substituent attached N nitrogen, so this becomes N-methyl, methyl substituent attached to it, and the parent chain for this becomes eth, 2 carbon atoms, 2 carbon atoms, it becomes eth, and N for saturation, and amine is a secondary suffix for this functional group. Now What if there were multiple substituents attached at our main chain? What happens then? Then we will go with the priority as discussed earlier. I'll write the all the substituent by their priority and also give you the name of the substituent when they come as the name of the functional group when they come as a substituent. Okay. So we learned this is the priority order. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if there were multiple functional groups present at the same chain, what happens is you have to get one of them, you have to give one of them the priority of becoming a parent functional group and the others become substituents. Okay, so what if they become substituents? So you will see the cases of these compounds becoming substituents. Okay, these functional groups becoming substituent, coming as substituents. So if the nitrile CN comes as a substituent, this becomes from nitrile to cyano. If aldehyde becomes like this group comes as substituent, what will its name changes from Al to formyl or oxo. We'll discuss the case what happens over here. Okay, if ketone becomes substituent, it becomes oxo from on. Okay, if alcohols, it becomes hydroxy, and if amine, it becomes amino. Okay, now we will take an example. Okay, now you must be able to name this compound. Here are two functional groups mentioned over here. One is, you can see it is ketonic functional group because it's two is present over here, and one is hydroxyl functional group, OH present. Okay, so the OH comes later than the ketones, so the ketones become our parent chain, so the secondary suffix in this case would be ONE, and this uh, alcohol becomes hydroxy because it is now coming as a substituent. Okay, secondary prefix now, substituent. So as a substituent, what would be its name? Its name would be hydroxy. So the name of this compound becomes 1, 2, 3, 4, 5, 4-hydroxy, and 5 carbon atoms. So pent, and AN for saturation, and ONE is the secondary. So 2 on AN for the saturation, and at carbon number 2 we have got our substituent. So 2 on, as it is a ketone. Now, what happens if a ketonic functional group and aldehydic functional groups comes together? Okay, now you must be able to name this compound. Okay, now we have got two functional groups, as one is ketone and the other one is aldehydic. Okay, which one gets priority? So now we know that the priority of aldehyde is greater than ketone. So we will have a secondary suffix is what? Al. Okay, secondary suffix of Al, and ketone becomes oxo. So 1, 2, 3, 4. We have got 3 oxo and 4 carbon atoms bute, and An for the saturation, and Al for what? For our secondary suffix. Is this is our functional group, main primary functional group, main functional group, primary functional group. Okay, let me give you one more example. Okay, now with the help of all the rules we learned, we must be able to name this compound now. So there are many functional groups present over here. One is the aldehydic functional group, the other one is ketonic functional group, the other one is alcoholic, the other one is amine, and the other one is acid. So which one gets priority? Our acid becomes our primary functional group because it is present at the top. So the secondary suffix for this compound would be oic acid. The others, all others become our substituents. So the name for this compound would be, we have to number our main chain. So 1, 2, 3, 4, 5, 6. So first of all, we have to name our substituent in alphabetical order. No one gets priority, or other one just the alphabetical order gets priority. Okay, we have amine. Amine A comes first. So 2 amino, and we have got formyl. Formyl group present at carbon number 5. So this becomes 5 formyl. Here was the rule I wanted to discuss. If you were to take your main chain of 6 carbon atom and count this carbon as one of the uh, one of the one of the carbons of your main chain, then you must name this group as oxo, not formyl. Okay, oxo, 6 oxo. Okay, if you are not including this carbon in your main chain and you are counting up to 5, so now this whole group is attached, this carbon is attached, this whole group is attached at carbon number 5 is formyl. So then the name of this functional group is formyl. So I have written it as formyl, and I have got 3 on carbon number 3. I have got hydroxy, and I have got oxo at carbon number 4, 4 oxo, and here we have got 5 carbon. So for the 5 carbon atom, the word root becomes pent, and An, as there is no unsaturation, pent N, and oic acid is the secondary suffix. So hope I have clarified my points all the way. So if there is any doubt, you can mention it in comments. Please let me know how you felt about it, and thank you for your time.